everyone. So today in this lecture, in this session, we are going to discuss the AIET test paper or the third AIET test. The code is mentioned here. You can see. So what I am assuming that you have taken the test and solved all of the questions after coming from the exam as well. So you have gone through all the questions. So I have selected a few questions which are important and the type of question which is important for your exam as well. So I hope you have taken pen and paper with you and you are also solving with me. You are also solving with me. On this note, I am starting the session. Okay. So let's start our session. First question on your screen. You can pause the question, you can pause right now and you can attempt by yourself, you can read the question. I'm assuming that you are solving the question by yourself. So if I read the question, what is it saying? Three conductors draw currents 1 ampere, 2 ampere and 3 ampere respectively when connected in turn across a battery. That means there are three conductors, and when they are connected with a battery one by one, they draw a current of 1 ampere, 2 ampere, and 3 ampere respectively. Okay. Now, if they are connected in series and the combination is connected to the same battery, the current drawn will be. Okay. Simple question. We can do this. Let's suppose there are three conductors. If there are three conductors, they will have some resistance as well. So let's suppose this is the first conductor and it has some resistance R1. This is the second conductor, has some resistance R2. And this is the third conductor, which has some resistance R3. And now these conductors are connected with a battery. With the same battery, I will say one by one, like this. You can see. Battery is same, V, let's suppose this battery is same. And each time they withdraw some current, like it is given as 1 ampere, in this situation 2 ampere, and in this situation it is 3 ampere. Clear? So now what I can say, you can calculate the values of R1, R2 and R3 using Ohm's law. Very simple situation. You can calculate the value of R1, R2 and R3. So R is equals to what? Using Ohm's law, V over I. Clear? So R1 will be V divided by 1. R2 will be what? V divided by current is 2 ampere. And R3 will be what? Potential divided by current is what? 3 ampere. Clear? This is clear. Now they are saying they are connected in series. Now all these resistors are connected in series. Like you can see R1, R2, and R3. R1, R2, and R3 are connected in series with the same battery. With the same battery, V. So the current in this circuit will be, they are asking. Okay. So can you see that if they are in series combination, then R equivalent will be what? R equivalent of the circuit will be R1 plus R2 plus R3 because this is series combination. And if you add these values, what you will get? If you can add these values, I hope you can get the LCM of these three values will be 6. So that will be 6V plus 3V plus 2V. That is 3 to 5, 6, 11V by 6. This is the R equivalent of the surface. Clear till now? I hope it is clear. R equivalent, you know, then I is equals to, or you will say I is equals to V divided by R equivalent, Ohm's law, nothing else. V equals to Ri, Ohm's law. Now V is what? Potential. R equivalent is what? 11V by 6. Can you say that V and V can be cancelled? That is 6 by 11 ampere. Isn't it doable question? All of you can solve it. I hope the concept is clear. Everything is delivered in the question. So which is correct option? Correct option number is A. A is the right answer. How many of you got it correct? I hope you are trying the question with me. So on this note, I am moving towards the next question. Next question on your screen. Okay. Again, you can pause the screen and start solving by yourself. So I will read the question. Two concentric spheres of radius r and r have positive charges q1 and q2. Okay. So let's draw. First of all, let's draw. This is one sphere and there is one more sphere. Let's suppose this is another sphere. Both are concentric like this. They have a common center. Okay. Now they have some charges q1 and q2. So let's suppose the radius of outer sphere is capital R and that of inner sphere is small r. I am assuming it. So capital R radius has a charge q1 and small r radius has a charge q2. But with equal charge densities, they have equal charge densities. This is again an important point. Equal surface charge densities. Okay. What is the electric potential at their common center? No problem. Now coming back to the solution part. If you know, let's suppose the center is O. So potential at the center will be due to two charges. One is Q1, another is Q2. So Q1 is a sphere. The potential at its surface or at its center will be same as the potential at the surface. You must know this line. That means what I'm saying, if you have a sphere, then the potential at its center will be same as the potential at its surface, and potential at the surface of a sphere is nothing but KEQ by R. So potential at the center O will be due to two charges Q1 and Q2. That is KE Q1 by R, that is the radius of the first sphere, plus KE Q2 by R. Clear? Done, I hope. Now, the options doesn't contain Q1 and Q2. It contains charge density. It contains charge density. I hope it should be mentioned in the question that equal charge density is sigma. Sigma is not mentioned in the question, but because an option it is given and equal charge density is given, so sigma must be there in the question. Okay. Now, they both have equal charge densities and equal charge densities, like I will say, sigma is equals to, for first sphere, I can say, what is sigma? Charge per unit area, that is Q1 divided by 4 pi r square. Q1. Clear? So Q1 can be written as sigma into 4 pi r square. Can you see that? Q1 can be written as sigma into 4 pi r square. Similarly, Q2 can be written as sigma into 4 pi small r square. Can you calculate these two values? Very simple. Now you know the values of Q1 and Q2. Put these values. And if I change the color of the pen so that it will look beautiful, V naught is equals to Ke is what? 1 by 4 pi epsilon. I hope you know that. 1 by 4 pi epsilon naught. Can I take it common? Can I take it common? Okay. There is one mistake. For Q2 charge, radius is what? Small r. Okay. Now, put the values of Q1. Q1 has a value sigma into 4 pi r square. Sigma into 4 pi r square divided by capital R is there. Plus Q2 has a value of sigma into 4 pi small r square divided by this r. You can cancel out few things. Small r, capital R, capital R. Powers cancelled. So what is again common? Sigma into 4 pi is common. Can you see that 4 pi and 4 pi will be cancelled? So V naught will be what? Sigma is out taken outside divided by epsilon naught. What's remaining? Capital R is remaining and here small r is remaining. So this is your answer, sigma by epsilon naught r plus r. Is it clear? So sigma by epsilon naught r plus r, which is correct option number A. You can see. Is it again doable in the exams? So these kind of questions actually come in your exams. So be ready for that. Moving further for the next question. Are you ready? Okay. This is a simple formula based question, nothing else. They are saying the limit of resolution of 100 centimeter telescope with visible light of wavelength some 5500 angstrom. So limit of resolution, you should remember the formula. Nothing special in it. It is denoted by theta. Limit of resolution is 1.22 lambda by d. The relation you should remember. And you can put the values now. That is going to be 1.22. Lambda is what? 5500. Angstrom is 10 to the power minus 10 divided by d. D is given as 100 centimeter. 100 centimeter means 1 meter. So this is the simplest calculation I can say. These two zeros can cancel out the decimal. So it can be written as 122 into 55. I can break it as 5 into 11 into 10 to power minus 10. I am just doing for my help actually. You can do it by yourself, whatever you want to do. So that is going to be 610 into 11 into 10 to power minus 10. And if I multiply with 11, that's the easiest task. 0, 6, 1, 7 into 10 raised to the power minus 10. So you can write it as theta is equals to 6.7. Okay, answer is in 67 point something like na. So you need to transform it in that way, not in the actual scientific way. So that is 67.1 into 10 raised to the power minus 8 radians, which is correct option number C. Which is correct option number C. This formula you should remember. And after knowing this formula that we are talking about telescope, you can also revise the formula for the microscope. Clear? And the magnifying power of the telescope, resolving power of the telescope, resolving power of the microscope. You can remember these two, three formulas. Okay. Now, this is an important kind of question. Very famous, but usually it can be asked in the examinations. Now, look at that. The question says this is a cube, and each of the wire has some resistance of what? 6 ohm. Clear? These wires, you can say, let's suppose there is a cube is formed. A cube is formed using wires, and each piece of wire has a resistance of 6 ohm. Okay. The current enters at a corner A and leaves at the diagonally opposite corner G. Clear? The joint resistance, or you can say equivalent resistance across the corners A and G, they are asking. Very popular question. First of all, what you can do, just connect a battery across the terminals. Let's suppose this is the battery connected. Clear? And let's suppose the potential of the battery is V. And what I'm saying, I will give you an idea what I'm saying. Let's suppose I will delete it after some time. Let's suppose, consider a circuit here. Consider a circuit here, for example, like this. You should feel the question actually. Let's suppose this is 3R, this is 3R, this is 3R, and there is a battery V. Okay. Now, what will be the current in the circuit? What will be the current in the circuit? So if you want to calculate current in the circuit, you will say, sir, current in the circuit will be I is equals to Ohm's law says V over R equivalent. Current supplied by the battery will be I is equals to V over R equivalent, or you can say R equivalent is V by I. Now listen to me very carefully. What is R equivalent is the potential of the battery divided by the current supplied by the battery. This is the current supplied by the battery. Clear? So if you can get the values of current supplied and the potential, the ratio of these two will give us R equivalent. This is a complex circuit. You will not find any series and parallel combination in it. If you can try, you will not find any series and parallel combination. Because if I say, what is the combination of these two, you can't say whether they are in series or in parallel. You can't say, because neither they are in series nor in parallel. So what is the method we are going to employ in this? We know that R equivalent is what? V divided by I, where I is the current supplied by the battery, total current supplied by the battery. Remember my word. Now coming back to the question. Is this concept clear? So what we are going to do, we are going to calculate this ratio to get our R equivalent. I hope this is clear. Now, I will delete some part so that we have some space. Otherwise, you will say what kind of circuit is that was. Now listen to me. Again, coming back to the question. What if I say, look at that. Hmm. What if I say, look at point A. It has 3 branches of 6 ohm connected like this. Similarly, if you look at point G, It also has three branches connected to the point G, and each branch has a resistance of 6 ohm. So this circuit has path symmetry about A and G. I am again repeating my words. This circuit has path symmetry about A and G. And if a circuit has path symmetry, then the current entering, or what is the meaning of path symmetry? How you can identify the path symmetries? Just switch the point, switch the names like A and G, switch the terminals A and G, or swap the terminals A and G with each other. And if there is no change in the circuit, then it means that there is a path symmetry in the circuit. Now, if you can say, I can replace it G and replace it with A, can you identify what happens, what changes are happening? No change is happening in the circuit because circuit is completely symmetrical. So it has path symmetry. And what is the meaning of path symmetry? The current entering at point A will reach point G symmetrically. Like if I current is moving in this direction or coming out in I, like suppose, then it will enter I. Clear? Are you getting my point? If it is entering 2I, then it will leave from G as 2I. Are you getting my point? This is the power of symmetry. The way current is entering from A, the same way it will leave from G. In this question, I am naming A and G. Otherwise, the 2 points, if 2 points have path symmetry, then the current entering from one point will be similar to the current leaving from the second point. So look at that. What I'm saying, 2I current is entering, let's suppose at A. Why 2I equal current? Because all these branches have equal resistance. They have same resistance, so same current will pass through it according to the symmetry. Now, why I have chosen 2I? Because look at this, at point E, this current will further break in two parts. This current will further break in two parts. So it will be easy for us to divide in I and I. Can you see this? Are you able to see the distribution of current? Now, similarly, this current 2I, which is coming along AB, will break in two parts at point B. One is I, another is I in the downward direction. Clear? I hope you can see this distribution of current. Then how much current will be supplied by the cell? 2I. Total 6I current is supplied by the cell. Clear? Now you can divide this 2I as well. This 2I will divide in two parts. One is I, another is I. Clear? I hope it is clear now. Now, what is your aim? Your aim or R equivalent will be what? Potential of the cell divided by the current supplied by the cell. Current supplied by the cell is what? 6I. If you can calculate this ratio, that will be your answer. That will be your answer. Now, what you can do to get this ratio? Apply KVL in any of the loop which includes the cell. In any of the loop which includes the cell, you can apply KVL. So I am giving you a path, like suppose A, this point is what? E, A, E, F, G. Can you identify the path? The cell, and coming back to A. Can you see this path? Is it a closed path? The point you started is A and point you finished is also A. So if I name this path in A, E, F, G, A. Clear? This is the path in which I am going to apply Kirchhoff law. Each of the wire has a resistance of 6 ohm. That is clear. So I can right now I will put the values. I hope you know how to apply KVL. I hope you know. In the direction of current, I will take it as positive. So that is going to be 12I. 6 is the resistance R into I, that is Ri. Potential difference, the sum of potential difference is 0. So resistance is what? 6 ohm. Current is what? 2I. So that is going to be 12I. Plus, in this E to F region, resistance is 6, current is I, that is 6I. That is I. Plus F to G, that is again 12I. Now, after that, I have moved towards battery. I am entering towards negative terminal, that is minus V is equals to 0. So, how many I's? 12, 12, 24, and 6, 30I is equals to V. So, V over I is equals to 30. But we need to calculate V over 6I. V over 6I. So, what you can do? Multiply it with 6, divide with 6. So this V over 6I is our R equivalent. V over 6I is our R equivalent, or this is 6 is equals to 30. So R equivalent is what? 5 ohm. How simple is the question? Using symmetry, you can understand. Using symmetry, how simple is it to solve the question? Is it clear? Moving further for the next question. Two bodies of masses m1 and m2 fall freely from height h1 and h2 respectively. The ratio of time taken by the bodies to fall through these heights. Like suppose this is a body which is falling freely by some up to some height, falling freely up to some height h1, and another body which is falling freely by a height h2. Clear? So what is the ratio of time taken? Very simple. You know the formula, S is equals to ut minus half gt square. So for first particle, if I say what is displacement, that is minus h1 is equals to u is 0 minus half g t1 square. And similarly, h2, or you can say minus h2 is equals to 0 minus half g t2 square. You can simplify, you can divide these two. Minus 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 can be cancelled. So h1 over h2 is equals to half g can be cancelled, that is t1 over t2 whole square. So what you can conclude, this is the simplest question, t1 over t2 is equals to root of h1 over h2, which is correct option number what? C. I hope you get this question very easy. If you want, you can slow down the speed and you can watch. Very simple. Nothing else. I did nothing. Another question. Pause, draw the diagram, at least draw the diagram and try thinking. A pendulum bob of mass m and length L is released from an angle theta with the vertical. Clear? The tension in the string when the bob is at the bottom of the string is. Okay, listen. First of all, draw the diagram. Let's suppose this is the support. A string. Let's suppose this is the string which has some mass m. This is the mass of the bob. Length of the string is L. Mass is m. The angle with the vertical is theta. The angle with the vertical is theta. Clear? The tension in the string when the bob is at the bottom. Now this bob, if you release, then this bob will reach somewhere here. You can see this bob will reach some point here. Clear? And this is the length of the string. Clear? Now tension they are asking. Now listen to me very carefully. First of all, if you try to draw the FBD, its mass will be mg acting in the downward direction and some tension T will be acting in the upward direction. Is it clear? Yes, sir, it is clear. Now, if tension T, can you see that if you drop or release a pendulum from here, it will go like that. Its path will be a circular path. Its path will be a circular path. So if it is revolving in a circular path, then there must be some centripetal force. There must be some centripetal force acting. So you can write here that T minus mg is equals to mv square by r. Centripetal force, you know that mv square by r. And r is what? Radius. So if the particle is hinged from this point, you can see it actually. Just imagine, look at me. Just imagine if a string is supported at this point, a bob is here, and it is moving like that. So how much radius of this circular path is the length of the rod, length of this string? So that is going to be L. Clear? Now T is what? Mg plus mv square by L. Let it be equation number 1. Now, if you can know what is the speed of the particle at this point, if you release this particle, this bob from here, it will have some velocity at the bottommost point. It will reach like that. So it will have some velocity. So what is your task? Your task is to calculate this velocity. And if you can calculate this velocity, you will get your answer. Okay. So for the calculation of the velocity, look at me. Let's suppose this is the horizontal line. Clear? And this is the initial point from where particle was released, and this is the final point of our interest, I and F. From initial to final, the mechanical energy of the system will remain conserved. The mechanical energy of the system will remain conserved, and the mechanical energy of the system is conserved. So you can apply conservation of mechanical energy, which says K initial plus U initial is equals to K final plus U final. I hope you know the conservation of mechanical energy theorem. Now, if you put some values, let's suppose this is our origin. This point is our origin. So K initial is what? 0. Particle was released from this point, initial point, I point, it is released. K initial is 0. Plus U initial is what? M, G. And what is this height? Total length is L. Can you see this length is L cos theta? This much length is L cos theta. In this right angle triangle, you can find it. This is L cos theta. So this remaining length is what? This remaining length is what? L minus L cos theta is equals to K final. K final is what? Half mv square plus U final is what? 0, because this is the origin. So from here, you can calculate the values of mv square. So what is the value of mv square? You will get 2 m g L 1 minus cos theta. This is the value of mv square. Is it clear? I hope it is clear to everyone. Just replace this value. So T is what? mg plus. Put exact value of mv square, that is 2mgl 1 minus cos theta divided by L. This L divided by L and L can be cancelled. So T is what? You can take mg common. What will remain? 1 is here plus you can multiply this 2 minus 2 cos theta. So tension will be what? T will be mg 3 minus 2 cos theta. This is your answer. mg 3 minus 2 cos theta, mg 3 minus 2 cos theta, and mg 3 minus 2 cos theta, mg. This is option number D. I hope the question is clear. This is again a very famous question for the NEET examination. You can read the next question. Okay. A rectangular loop has a sliding connector PQ, okay, of length L and resistance RO, okay, and it is moving with speed V as shown in the diagram. Okay, the setup is placed in a uniform magnetic field going into the plane of the paper. That is, magnetic field is into the paper. The three currents I1, I2, and IR. Okay, look at me. I will draw the diagram. Look at that. These are the conducting rails, you can say. Clear? This is some resistance. This is again some resistance. And this middle wire is moving. With in the horizontal direction with some velocity v, and there is a magnetic field B into the plane. And all these resistances are R. Clear? Now, if you can see, if this middle wire is moving in the horizontal direction, there will be some motional EMF induced in this rod. And the motional EMF will have some positive terminal V cross V. If you do, it's, it can be treated as a battery which has this terminal as positive and this terminal is negative. And this is the EMF. Now, this is the simple circuit. In this circuit, there will be some current, like current is given as I in this branch, and I1 in this branch, I2 in this branch. Clear? I hope it is clear. And all the resistances are R ohm. Now, can you solve this circuit? What is the value of EMF? First of all, you should know that thing. Sorry. So if I say EMF is equals to BLV, everybody knows motional EMF is BLV. So if motional EMF is BLV, so what is the R equivalent of the circuit? What is the R equivalent of the circuit? You can clearly state this R and this R, both are connected in parallel. So they have an equivalent resistance R by 2. I am writing R equivalent. This R and this R are connected in parallel, so they will have an equivalent resistance R by 2. Now the combination of these two is connected in series with this R, that is plus R. That will be 3R by, this is the equivalent resistance. Easiest thing of the question, R equivalent. So what will be the total current? I will say I is equals to E by R equivalent. That is EMF is BLV by R equivalent is what? 3R by 2. So 2 can be transferred here. So I is equals to 2 BLV by 3R. 2 BLV by 3R. So this is in option B only. 2 BLV by 3R. This is the value of current I. Now again, if you look, this current I is divided in two parts. One is I1, another is I2. And both these two parts have same resistance R and connected in parallel. That means this current is going to be divided equally in two parts. And if you divide current I in two parts, so I1 and I2 both will be equal and equals to half of the original current, that is BLV by 3R. Not much is written on the board. The thing that I told you, it should be clear because the I current, the total current is going to divide in two parts, two resistors which are in parallel. So in both the parts, potential is also same, resistance is also same, so current will also be same. Not a big thing to understand. Why potential is same? Because they are in parallel. I hope it is clear to everyone. If you try to understand, the things are very much clear. Think about it. Moving further. Okay, this is a difficult one. Okay. White light reflected from a soap film has a maxima at 600 nanometer and a minima at 450 nanometer with no minimum in between. Then the thickness of the film is. Now, the question belongs to interference of light, but not like YDSE. It is interference of light from the thin film. So this question is from thin film interference. So first of all, if I write the topic, the question belongs to thin film interference. I hope you have studied this topic in your classes. Clear? And if you have not studied, so it's not the right time to discuss. You can ask, I will discuss this topic in the classes. So I'm assuming that you know the topic. What is thin film interference? Because it will take a lot of time if I explain. So one thing you should know, or you must know, I can say that for maxima to occur, for maxima to occur, the interference should be constructive. The interference should be constructive, and for minima, the interference should be destructive. That thing you know. Okay. So now, what is the condition for constructive interference in thin film? Like suppose this is the film. This is the thin film. Lot of things happen. I can't, I just don't want to confuse you. But suppose this film has a thickness T. This film, like this is a thin film. Width, you can say it is a soap film, which has some thickness T and has some refractive index mu. So the condition for constructive interference is 2 mu T, 2 mu T is equals to n plus 1 by 2 lambda. Clear? N plus 1 by 2 lambda, where n is some integer 0, 1, 2, 3, 4 kind of values. Now, For destructive interference, this is for constructive condition. I have not written. This is for maxima or constructive interference. And for destructive interference, I will say for minima, this condition is 2 mu t is equals to n lambda. Now, one thing, both the terms involve some n relation. Both the terms have some relation n, including n. So these two values can't be same, that like we can't use n for both the terms. So for the simplicity, I am doing this n belongs to constructive interference, this n belongs to destructive interference. This lambda belongs to constructive interference, this lambda belongs to destructive interference. Clear? So constructive interference, lambda C has 600 nanometer and lambda D has a value of destructive interference has a value of 450 nanometer. You know these values. Now, they want you to calculate the thickness. Can you see if you compare these two equations, 1 and 2, the LHS is same. So RHS must be same. Clear? So comparing these two equations, NC plus 1 by 2 lambda C is equals to ND lambda D, where D stands for destructive, C stands for constructive. Clear? Now, if these two terms are equal, look at me very carefully. Look at me. Can you see that lambda constructive is more 600? Lambda constructive is 600 and lambda destructive is 450. Clear? This is only 450. So this n destructive, what I can say, I can write these things here. Lambda constructive is greater than lambda destructive. So n for constructive should be less than n for destructive. Clear? Only then these two equations will be balanced. Now, otherwise it can't be balanced. They can't be equal otherwise. So NC should be less than ND. Clear? Now, let's suppose this ND has a value of n. Then this NC should have a value less than n. But one thing is there is no minimum in between. Only if there is no other minimum in between, then after one minima, there will be another maxima. So this NC will be n minus 1 only. It can't be n minus 2, can't be n minus 3, because there is no other minima. So these two are consecutive. If these two are consecutive, so n should also be consecutive. If this is n, this should be n minus 1. Now put these values. Now NC, in place of NC, I am writing n minus 1. N minus 1 plus 1 by 2 already there. And this lambda C is what? 600. Nanometer I am not going to put because nanometer will be cancelled, is equals to ND is what? N. Lambda D is what? 450. Now you can simplify these terms. 0 and 0. 15, 3, 15, 4. So if you simplify this is n minus 1 by 2. N minus 1 by 2 multiplied by 4 is equals to 3n. Or can you say that 4n minus 2 is equals to 3n? Or n is equals to 2. That means n is coming out to be 2. Now put this value in equation 2. From equation 2, if I say 2 refractive index is given as 1.5. 1.5 into T is equals to ND. ND is what? N is what? 2. Lambda is what? Lambda D is what? 450. 450 into 10 to the power minus 9 nanometer. Can you see that? Simplify it. This is going to be 1.5 into 2 is going to be 3. 3 you can cancel out 150 times. So T is going to be 150 into 2, that is 300 into 10 to power minus 9, or that is going to be 3 into 10 to the power minus 7 meter. And question is into 10 to power minus 7 meters. So what is 3 into 10 to power minus 7 meter, which is correct option number C. I hope the question is clear. So what you can take from this question, if somehow it comes in your exam, what you should remember, that condition. Okay, listen to me. This is some complex question. The value of question, the level of question might be little bit lower than this. Then at least what you should take from this question, these condition of maximas and these condition of minimas you must remember. You never know what question may come in your exam. Like they will give you some values, or you need to find, you T is given, you need to find N, what any sort of values it might be possible. So you should remember the condition of maxima and minima for soap film. And these conditions are when light is falling vertically or normal to the surface. These conditions are valid only in that situation when this light is falling vertically. Otherwise, these conditions, some slight change will be there. But in the NEET exam, that will be enough. Moving further. Next question. A hollow spherical conductor has a charge 500 microcoulomb and has a radius of 202 meters. The electric field near its surface is. So electric field near its surface is KEQ by R square. You can put the values and you will get the answer. I am not going to solve it. You can put the values and you will get the answer. What is R? R is the radius. R is the radius square. You will get the answer. I don't think it is important for me to solve. Moving further for the next question. How much time we have? Okay, we have some 4-5 minutes left. Okay. So what is the question? Electric field in a region E is given as m over x cube I cap. Then the correct expression for the potential in the region, assume potential at infinity to be 0. So you know the relation dV is equals to minus E dot dr. So if you can put the relation dV is equals to minus E has a value m over x cube in the I cap direction dx. So for complete, you can integrate it. If you integrate it, what it will become? V is equals to minus is already there, m is a constant, and if you integrate 1 over x cube, that will be, you can take it x raised to power minus 3. So that is x raised to power minus 2, that is x square divided by minus 2. Divided by minus 2. So minus and minus can be cancelled, that is m over 2x square. Is it clear? So V is equals to m over 2x square, which is nothing but option number A is correct. Next question. Consider the charge configuration and a spherical Gaussian surface as shown. This is Q1 minus Q1 and Q2. While calculating the flux of the electric field over the spherical, the electric field will be due to all the charges. Electric field will be considered due to all the charges. You know this. This is. Now, in this question, a uniform electric field in the plane of paper is shown. Okay, this is electric field. Here, A, B, C, D are 4 points on the circle. V1, V2, V3, V4 are the potential at those points respectively. Then which option is true? Now, one line that you should know, in the direction of field, in the direction of field, potential decreases. Potential decreases. That means if you move in the direction of field, then potential will decrease. So can you say that which point will have maximum potential? Point C will have maximum potential and point D will have minimum potential. Option you can find by yourself. C has maximum potential. As you move in the direction of field, the potential will decrease. So C has maximum, D has minimum. Now can you see that these A and B are on the same vertical position? That means A and B will have same potential. A and B have same potential. Now find the options. This option is saying VA is equals to VC, which is wrong. This option is saying VA is equals to VB. This part is correct. And VC is greater than VD. This part is also correct. So option B is correct. Clear? Moving further for the last question. I hope the time is done actually. So I'm not going to involve a lot of more questions. Some more questions are here. Okay. Okay. So I hope you can understand. Time is over actually. So we are not solving further. Bye everyone. I hope you enjoyed the session. Bye bye. See you later.